Okay, so today we're going to talk about families of polynomials. According to this definition here that I've got for you, a family of polynomials all have the same roots, but are different graphs, basically, or different equations. So, graphically, an example of that would be something like this parabola here, and then another parabola that has the same roots but happens to be a different graph, or even this parabola here this is a family of three parabolas, actually. One being the normal parabola that's maybe been shifted over and shifted down. Then this one here that's been maybe shifted over and then flipped and shifted up. And then this one here that's the same, but it has, notice how they all have the same roots, but they're different graphs. That's basically the idea. I'll show you some on the calculator as well. If we look at this calculator, I have three third degree functions. One is x to the third minus 3x plus 1. The other one is 2 times x to the third minus 3x plus 1. And the other one is a negative x to the third minus 3x plus 1. So we'll see, notice the first, then the second, and the third. We'll see how they are actually all different when we graph them, but in the end they all have the same roots, okay? And so let me go ahead and graph these here. I'll go to second and graph. So there's the first one. Notice it's got three roots. And the second one has the same roots. There it is. And the third one, comes in from the top, same three roots, but they all are different graphs. Those are families of polynomials. Notice the difference that we had there. Let me go back to the y equals screen. So the point of this was to notice the difference in the equations. Okay, basically these polynomials are all the same, except the first one has nothing multiplied by it, the second one has a 2 multiplied by it, and the third one has a negative number multiplied by it. Okay, and so what that means is a family of polynomials would look something like this on paper. Let's go ahead and write it down right here. So example, this was an example of the graph over here. Now here we'll do an example of what the equations might look like. So I might have 2x squared plus 5. This could be a polynomial. And let's say I've got f of x equals 6 times 2x squared plus 5. Basically, all it is you take the original function, place it in here, multiply it by a different number, and you're going to produce another member of the family of polynomials. Okay? And so that's kind of the idea. It's just a vocabulary word, more or less. Family of polynomials. And so that's kind of the idea behind that. Now, what would be a sample question? So an example question would be, determine an equation of a polynomial. Determine an equation of a polynomial with roots -2, 4, and 6 that goes through the point 1, 8. Okay? And so what I'm going to do here is try and solve this question. this is basically what a question you'll get on the test and some of the homework questions. So in order to ensure that my polynomial has these roots, -2, 4, and 6, I build the following polynomial: x minus a -2, or x plus 2. Okay? Then x minus a +4, or x plus 4. Oops, this should have been a minus right there. And x minus 6. So this is my polynomial here that has these roots. So determine an equation of a polynomial with these roots. That is taken care of. Now I have to make sure that it goes through this point. In order to ensure that it goes through this point, what I'm going to need to do is I'm going to need to take my polynomial here, and I'm going to need to multiply it by some mysterious number to make sure that it's either stretched or compressed so that it goes through 1/8. Okay? So my polynomial currently might look like this. Alright, let me just move my drink over there. My polynomial might look like this. It definitely goes through 2, 4, and 6. Sorry, -2, 4, and 6. So -2, 4, and 6. So it definitely goes through here, here, and here. Alright? And currently I have a third degree positive polynomial. So the end behavior is going to be something like this. Alright? So this is what I currently have. Now I'm not entirely sure whether or not it goes through 1/8. 1, 2, 3, 4, 5, 6, 7, 8. This point up there. I need to make sure that it goes through 1/8. So what I need to do, but the thing that I can't do, a lot of people think, well, I'll just take this and shift it up. That's not going to work, because I need to make sure that it has these roots in the end. So the only way to make it so that I don't mess with the roots, but I go through that point, is either to stretch this polynomial up, okay, or compress it down, if perhaps maybe I needed it to go through 1, 2. Okay, and the only way to stretch or compress a polynomial is to multiply it by some random number. I'm going to choose that number to be k. Okay, so this is my polynomial. F of x is equal to some random number. That number is hopefully going to be the correct number by the end of the question. It's not correct yet, so that it goes through 1/8, but it still keeps these roots. Okay, so this is the idea. Excuse me. And so, how do I make it so that it goes through 1/8? Well, notice that 1/8 is an x and a y coordinate. And in this polynomial, I've got x's here, here, and here, and I've got a y right there. So basically, all I do is I put my 8 in for y, and I put my 1 in for the x's, but I leave the k. 1 plus 2 here. 1 minus 4. And 1 minus 6. And so this is now basically the end of the question. And what I need to do here is solve for k. And then this is going to be the correct polynomial. In the end, I'm going to write my polynomial f of x is equal to x plus 2, x minus 4, x minus 6, and I'm going to place k right there. But I have to find k right over here real fast, though. But thankfully, I know algebra, and I can just find k. K times 3 remember parentheses first here. 1 plus 2 is 3. 1 minus 4 is a negative 3. 1 minus 6 is a negative 5. And so I would say 8 is equal to 3 times 3 is 9, which is a negative 9. Negative 9 times negative 5 is 45. And so k value is 45. There we go. So I've got 8 equals k times 45, divide by 45, divide by 45. It turns out that my k value is 8/45. So if I take this number and I place it here, this is now going to be the correct polynomial. Let me look over there. And so what that means back on our graph is, I actually drew the original graph a little incorrectly. The original graph without the k, x plus 2, x times x minus 4, times x minus excuse me, x plus 2, x minus 4, and x minus 6. That original graph was something like this. Right there. And what we actually needed to do is we needed to multiply it by 8/45 to compress it so that this point would actually arrive at 8. So I was actually 8/45 too high on my original graph. I was actually 8/45 too high in a way. Actually, I should probably say 45/8 too high. But then what will happen is, if I find the k value and I write this formula here, you'll notice that this function right here actually has the roots that we need. So let's zoom back out again. Whoop, there we go. So I needed to determine an equation of a polynomial that goes through -2, 4, and 6. So this polynomial does go through -2, 4, and 6 because it has those roots. But then I needed to also make sure that it goes through 1, 8. And so in order to make sure that it goes through 1, 8, I place the 1 here, here, and here, the 8 there, put a mystery k, solve for it, then the k goes in. And so this polynomial does satisfy all of those conditions. Okay? Now, there's one other thing that you'll maybe need to look at. Now, let me get a spare piece of paper. Here we go. What if the polynomial says this? Find a polynomial that has roots two and 3 plus or minus the square root of let's pick a number, 5, and goes through 4, 6. 4, 6. This is gonna work. Okay, so I have to find this polynomial. So before, all we would do is write the roots out. This is a 2, so I would write x minus 2. But how do we write these roots here? So remember before I had find a polynomial that goes through 2, 4, and 6. Negative 2, 4, and 6, so I would go positive 2, negative 4, negative 6 to make my original polynomial. Now for this one, it goes through 2, I go through negative 2, but it goes through this funny root here. I would actually just go x minus, remember, if my root is 2, I go x minus 2. If my root is 3 plus the square root of 5, I go x minus 3 plus the square root of 5, and I'll have to put that in parentheses. So there I have that. Then the other one, remember this is plus and minus here. And so I get x plus 3 plus, minus here. These should both be minuses. Just like this is a minus. And I did 3 plus the square root of 5, and now I need to do 3 minus the square root of 5. Okay? So you set this up. Then so this is basically my polynomial here. Okay? It has the roots negative 2. It has the root 3 plus the square root of 5, and the root 3 minus the square root of 5. Remember, these dark ones are going to be minuses, all of these. Everything on this page is a minus except for this. And now I put in my k value, and this is my polynomial. I need to make sure that it goes through 4, 6. So I place a 4 in here, here, and here, and I place a 6 in right there. So I just go 6 is equal to k times 4 minus 2 times 4 minus 3 minus square root of 5. Remember, if I have a minus out here, it distributes in so that this actually changes as well. And then 4 minus 3 plus the square root of 5 as well. And now I can solve for k here. For these numbers, you can put them in decimals here on your calculator. So I would do 4 minus 3 minus the square root of 5. Change the square root of 5 into a decimal and go ahead and take care of that there. Okay? And so basically I solve for k. The other format that you would have is if you're given a graph. It says find the polynomial. So the polynomial will look like this. And it will have roots. And it'll give you a single point here as well. Excuse me. So what I've got is this polynomial goes through negative 4 right here for a root, goes through negative 1 for a root, and it goes through positive 2 for a root. You see that? And so I would set up my roots. Negative 4 would be x plus 4. Negative 1 would be x plus 1. Positive 2 would be x minus 2. Then I would put in my k value. And this is f of x. Now I would use this point for my x and my y here. So this point right here looks to be 1, -2, let's see, -2, comma 3. So to make sure it goes through -2, 3, I would put a 3 here and a -2 here, here, and here. So I would say 3 is equal to k times -2 plus 4 times -2 plus 1 times a -2 minus 2. Okay? Then I would solve for k. Okay? And so that's basically how you're going to see it, and that is families of polynomials. Okay?